So this is number 77. And the title is Equation of a Circle. So I know you know all this already, but we haven't written it down. So a circle is the set of all points the same distance from the center. Circle is the set of all points the same distance from the center. So here's the center. And let's just temporarily pretend that this center is 2, 3. So what I mean by that is to get there you went over 2 and up 3. All right, then I want to go the same distance in every direction. Let's say it's 5 inches. So I'm going to go 5 inches this way. And that gets me to a point that's on the circle. And then I'm going to go 5 inches this way. And that gets me to another point that's on the circle. And I'm going to go 5 inches this way, 5 inches this way, 5 inches this way. So the circle is all of the points that are 5 inches from the center. So 5, 5, 5, 5. See how after a while it starts looking like a circle if you go 5 inches in every direction? So that's what a circle is. I don't know if I did this perfectly, but we'll see how it connects. Not too bad. So 5, 5, 5, 5. All these dots are 5 inches from the center. So what our goal is today is to find an equation for all of those points, for all those dots. But before we get to that, I want to remind you that for a line, for all the dots on a line, the template is y equals mx plus b. So maybe for a particular line, the slope is 3. And maybe the y-intercept is 1. So this is the template for all lines. This is a particular line. And what the equation does is all the dots work in this. So what I mean by that is maybe this dot is 1, 4. And if you stick a 1 and a 4 in, it works. See how that side comes out to 4 and this side's coming out to 4? So that's what I mean by it working. Or maybe for this dot, it's 0, 1. So if you stick a 0 in and a 1 in, it works. Okay, so the idea behind equation is this equation works for all those dots on the line. So we're going to go for the same thing except for a circle. So we want something that all of these dots are going to work in. So I'm just going to call this dot x, y. It's a dot that represents all the dots. So this one could be called x, y. This one could be called x, y. All right, now what is this 5? It's the radius, right? how far is it from here to here? 5 inches. So it's the distance between these points. So I'm going to do the distance formula. This is one of the reasons I reminded you about distance formula yesterday, because I knew it was coming up today. Plus, you need to know distance formula. So I'm going to do the distance between these 2 points. So the way you do that is you do y minus y and then square it. And then what? How does the distance form? Yeah.
Plus x minus 2 squared.
Good. So plus after that, and then x minus 2. And that should equal the distance squared, right? When you're doing distance formula, you subtract the y's and square it, subtract the x's and square it, and that equals the distance squared. So what is the distance on this one? 5, so it should equal 5 squared. Okay, so this is a formula or an equation that would work for all of these dots, because all of these dots are 5 away from that, right? So this is the equation for this circle. Just like this is the equation for this line, because all these dots work in this, and over there, all of these dots work in this. Okay, but this equation is just for this circle. And I want it to work for any circle. So what I'm about to write is the equation for any circle. So the way that goes is it's y minus y1 squared plus x minus x1 squared equals and then over here we need to take the radius and square it. Like here we did 5 squared, but 5 was the radius. So in general, we have to take the radius, whatever it is, and square it. All right, so that means that the center for this circle is x1 comma y1. And of course, the radius is off. Okay, so the idea is this right here, y equals mx plus b, is the template that works for any line. And then this is a particular line. And then over here, this is the template that works for any circle. And then this is a particular circle. All right, title of the paper is also Equation of a Circle. I'll pass out the whole bunch in a second, but get out a sheet of paper and title it Equation of a Circle. And we're going to start with number 4. All right, so here's the picture for number 4. This is what the problem gave you, so you don't have to write this down. It gave us the graph of a circle. First thing they asked for is the center of the circle. So we just have to start here and figure out what point that is. So it's 1, 2, 3, 4, 5, 6. That's backwards, so it's -6. And then 1, 2, 3, 4, 5, 6, 7, 8. So it's -6, 8 to get to the center. So that's not hard at all. You just look at the graph, find the center of the circle, and then count what point it is. All right, then the next question is, what is the radius? So to figure out the radius, you have to go to the center and then count how far it is out to the edge, or up to here or out to there. It doesn't matter which way you go because all the radii are the same, right? So it's 2. So radius is not bad either. You just go to the center of the circle and count out how far you need to go to get to the edge. All right, then it asks for the equation. So that means this thing. So it's going to be y minus 8 Everybody okay? And then plus x minus, this is a little bit awkward, but it's minus a -6. See where I'm getting this? And then you do the radius squared. And then I would probably go one step further from that. This is fine. I don't really like writing minus a negative, so minus a negative is the same as plus. And then 2 squared means 2 times 2, which is 4. Everybody okay? All right, now it also asks for the area of the circle. So how do you find the area of a circle? It's been a while since we did that. It's pi times radius squared. Radius on this one is 2, so it's 4 pi. Then they also ask for the circumference. Circumference is 2 pi r. This is a complete coincidence that they're the same answer, right? I mean, if this was a 3, then this would be 9 pi, and this would be 6 pi, right? Don't start thinking that area and circumference are the same thing just because we got the same answer one time. They're not. All right, next one is number 8. This time they're giving you the equation of the circle, So they said, here is the equation of a circle. And then they're going to ask some questions about it. There's a couple things that are kind of weird with this equation. What are they doing? Yeah. Yeah, the x's and the y's are switched. The template I gave you has the y's first and then the x's. And then they put the x's first and then the y's. But this is a plus sign, right? And you're allowed to swap across plus. So it's not a big deal. So we could take this and put it here, and we could take that and put it there. Because it's plus. You can switch across plus. That's called the commutative property of addition. All right, so that is a little bit awkward that they put the x's first and we're used to them. The reason I wanted to put the y's first is because when we do distance formula, we do the y's first. And when we do slope formula, we do the y's first. So I just thought it would be more consistent with the way that we do things in this class to put the y's first, so that you would recognize it as the distance formula. Because really, this is all based on distance. A circle is every point that's the same distance. That's why this looks like distance formula. It's not a coincidence. Okay, what else is, anything else that's awkward about the way they wrote this? Yeah. The 16 is not squared. So that means that they already figured out the number squared. So what is the radius then for this circle? 4, because this is 4 squared. Okay, so one of the questions they asked is, what is the radius? They gave you this template, and they gave you this equation. They said, what's the radius? The radius is 4 because they already figured out the 4 squared was 16. Okay, then the other thing they're asking on this question is, what is the center of the circle? So anybody want to give that a shot? What's the center of that circle? Yeah, Emma? I like the 9. I like the -3. But you set them in the wrong order because the x has to come first. Now, the reason you set them in the wrong order is because I set you up kind of to make that mistake, so I'm sorry about that. Because I had the y's first over here, right? You see what she did? It makes complete sense. It's a slight mistake she made. So the x value is 9. And here's something really smart that she did. The y is -3. Do you see why the y is -3? Because if we wanted to, we could rewrite this as minus a negative. That's the same thing as y minus -3 there. So what is being subtracted is the -3. So that was really good that she caught that. Because it would be very easy to just put 3 here and not notice that that was a plus. All right, the last one I'm going to do is number 16. And we got x squared plus y squared minus 2x plus 6y equals 0. Now, believe it or not, this is a circle. It doesn't look like this at all. So, in order to convince you that it's a circle, I'm going to do a bunch of crazy algebra, and I'm going to make this look like this. It's a lot of fun. Are you ready? Yeah, it seems like you're really happy about this. Okay, so the first step is I'd like to group these x's together. and I'm going to leave a space, and then I'd also like to group the y's together. It just makes sense to me to put these x's with these x's, and these y's with those y's. Oops, I missed something when I copied down this equation, I think. Yes, I missed a plus 3. Very sorry. Sorry, the original problem actually had a plus 3 in it, and I miscopied it. I haven't included it yet. I'm going to put it over here. But if I move it over there, it's minus 3, negative 3. I'd have to subtract it over to there, right? I just wanted to get it out of the way. All right, now what I'm going to do, this is called completing the square. You did it a couple days in algebra, but you don't remember it all, and that's totally fine. I don't expect that you remember this. Okay, so the way you complete the square is you look at this number, and you take half of it, and you square it. So that's a 6. So half of that is 3, and then 3 squared is 9. And so what I want to do is add 9 in this space. But I have to be careful. If I add 9 on the right side, I guess it's the left side for you. If I add 9 on the left side, I have to add 9 on this side also to keep things equal, right? So if I put a plus 9 there, I better put a plus 9 over there. I could put plus 5 and plus 5. That would also be legal. I could put plus 58 and plus 58. That would also be legal. But there's a particular reason why I want it to be 9, and I'll show you in a little bit. Okay, so now for this spot, I'm going to take half of this number and square it. Half of negative 2 is negative 1, and then negative 1 squared is positive 1. So I'd like to add 1 there. But if I put plus 1 there, I need to also put plus 1 there. So that process was called completing the square. Okay, now here's why I did that. Because now this will factor. So I'm looking at this, and I put a y here and a y here. Because y times y is y squared. Now I need two numbers that multiply to be 9. Yes?
3 and 3.
3 and 3 is a good option because it adds up to 6. But just for fun, what else multiplies to be 9? 9 and 1, right? But 9 and 1 is not what we want this time because 9 and 1 add up to 10. If that was a 10, then we'd want 9 and 1. But since it's a 6, we want 3 and 3. Then there's a plus sign in front of that. Okay, now I'm going to do the same thing with the x's. So you put an x here and an x here. And this time we're looking for two numbers that multiply to be 1. So what are two numbers that multiply to be 1? 1 times 1 is one possibility. There's another option though. Yeah. Negative 1 times negative 1 is positive 1 as well, right? And negative 1 and negative 1 are the ones we want, haha, because that adds up to negative 2. So you put negative 1 and negative 1. Then this side adds up, 9 plus 1 is 10, 10 minus 3 is 7. So that side comes out to 7. Okay, so now this is y plus 3 times itself. That's y plus 3 squared. And this is x minus 1 times itself. So that's x minus 1 squared. So I told you that this was a disguised circle. Then I did some crazy algebra. Now do you recognize it as a circle? So now it fits our template that we're used to. What is the center of this circle? Yeah, Maddie? 1 comma negative 3 is correct. Everybody okay with that? And then the radius. Yeah, that. This is supposed to be the radius squared, right? What number squared is 7? Not a nice number, right? So what number squared is 7? No. 3.5 times 3.5 is bigger than 9.
I was just adding.
Yes, you were just adding, which is what a typical thing. Yes, that's great. Thanks for speaking up, because I bet there were other people that were thinking that too. Yeah. So it's a big nasty decimal. So Taylor typed this into his calculator. He took the square root of 7. See why he's doing the square root of 7? And he typed it in his calculator, and it's this big nasty decimal. I don't want to write that down. The radius is the square root of 7. All right, are you feeling okay? Well, except for this crazy algebra. You don't like that. That's it. I get that. But are you feeling okay with this? Feeling okay with being able to do this stuff over here? Okay, thanks for listening.